fourth day of our one-week virtual faculty development program on emerging research trends in computer technology. It's
Recording
time to
in
start our
progress.
session. May I now request our today's session in charge, Dr.G. Gunasekharan sir, Professor, Department of Computer Science and Engineering, to take over the session and brief about today's session speaker. Please, sir.
Yes. Good afternoon, all dear participants. Really, I'm happy to introduce today's guest speaker, Dr.G. Rosline, Nesa, Kumari. Currently, she is working as a professor in Department of CSC, Bharath Institute of Higher Education and Research. She is having more than 19 years of experience in the various reputed organizations. She is a hardworking employee with a lot of research experience in various fields like digital image processing, AI, ML, and data science. She is a result-oriented individual with the expertise in career development, higher education strategy, and human resource development. Also, she is an excellent team player with a proven track record. She is a life member of various professional bodies such as CSC, CSI, ISCA, IET, etc. She has received many awards from various bodies for the performance on engineering. Cash Award for more publication in the year of 2014-15, 15-16. She is also appreciated 3 times in Teachers' Day celebrations from the management of GIET for the paper publication. And also, she is guided 2 scholars already. Currently, 10 scholars are working under her. And also, she has published 3 patents. And also, she is involved with various funded activities, received an acceptance from the UGC Minor Research Project, and also applied Swarna Jyoti Fellowship in DST, and also applied a research grant in Startup Research Grant, and also Career Award for Young Teachers to AICT in the year of 2013 and 14. Applied for a grant to conduct a workshop on mobile conducting with the Android application development to Naval Research Board in the academic year 2013-14. And also she has published books in the field of like computer organization and architecture and advanced algorithm. And also she has published nearly 62 journals, out of which 39 Scopus Index and 47 SCE Index and other journals 16. She has published papers in the international and national conference nearly 30. And also, Madam involved with various academic activities such as international conference chair in the year of 2020 and also in the year of 2017. And also, she has involved with IET special coordinator at Savitha University, Chennai, and also having experience in NAC at Savitha University, Chennai. And also, Madam involved as a editor of conference proceeding ICHCI 16 in GIET Rajamundry. And also technical reviewer of various journals like FICTA 2014 in the year of 2014 under Springer, and also technical reviewer of IC3T in the year of 2015. And also external reviewer board of advances in intelligent systems and computing, proceedings of the second international conference on computer and communication technologies by Springer, and also having experience as a NBA coordinator at GIET Rajamundry. Such a great personality, Dr. Rosline Madam has accepted for our workshop or for this FDP. So really very Madam. Thank you so much.
Thank you so much, sir. Thank you. Very good. Good afternoon to one and all. See, very nicely he read my resume or all these. So thank you so much, sir. Today I'm going to, it's audible, sir. My voice is audible, no?
Yes, ma'am.
Yes. See, now I'm going to be, say, first of all, I have to be thanks to Dr. MJ University management and as well as the faculties and students to given this opportunity to deliver a speech in emerging trends in machine learning based image processing. Thank you, sir. So today, just what I planned to tell about this, what is the image processing and what are the applications will be there, then how we can able to go for our research, all these, just I wanted to be tell about today. If you are having any doubts or whatever it may, anything you want to interact, you can able to note down in the end of the sessions. We will discuss about what you are expecting. So today agenda is, I'm going to be tell about some of the introduction about this concept of my title and the concept of image processing, application and fundamental steps and machine learning and deep learning. I'm going to be tell about how it is we can able to relate it to with this image processing. I'm going to be conclude. Next, first I'm going to tell about what is image processing. Image, that input here the input is the image. With the input, we are going to be do some of the process of transferring the image into the digital form, and we are going to be performing some of the operations to get some useful information from the images. So that is called the image processing. This image processing system, we can able to treat lot of images, maybe 2D signals or 3D signals. We can able to applying and predefine the signal processing methods. What's the concept behind this image processing? This image may be defined as two-dimensional function f of x comma y, where x and y are the spatial plane coordinators and the amplitude of f at any pair of the coordinates x and y. That particular x and y we are calling is the intensity, or we can able to call the, we can say it's a gray level of the image at the particular point. When x and y and amplitude value of f are all finite only here, and it's a discrete quantities, and we can call image a digital image. See, this is the which I'm showing now. My screen is visible, sir. My screen is visible?
No, ma'am.
No, ma'am.
It's not visible.
No.
No.
We can see the four PPTs. That's it.
Yes.
Now, sir, now it is visible. Now it's visible.
Yes, concept
Yes.
of image processing. Yes,
Yeah.
ma'am.
Yes.
No?
Yes. Yes.
Oh,
Yes.
okay. I
Now
thought
it's visible, ma'am.
already I shared, no, so that's why I continued. Okay, sir. See, now I'm going, which I'm showing, no, this is like one of the pic, that is an image. This image, the particular point is called the pixel. That is called xy. Just now while I said, no, f of x comma y is a sum of the intensity value, or we can able to say the gray level value. So that value, no, depends upon the image type. The value of the pixel, the intensity will be vary. For I'm going to be saying what are the types will be there and all. Next, this image, this particular pixel is the point of the image that is going to be take specific shades or colors also will be there. We are having the different type of images. First example, I can able to say it's a binary image. Binary image means the intensity value, the f of x comma y, that is equal to 0 or 1 only. Suppose the image is a grayscale. Grayscale means usually we people will say black and white image, but black and white is not, according to the digital, that is not a black and white, it's a grayscale image. The value of the grayscale intensity value will be 0 to 255. Binary means zeros or 1 only will be the grayscale means 0 to 255. RGB. RGB means the each pixel is having 3 different values. That means RGB. The R is having the 0 to 255 and the G is also having the value of 0 to 255 and B is also having the value of 0 to 255. The RGBA, it is going to be extensions of the RGB with the added alpha points will be the, that will be represented as opacity of the image. Next, type of processing. The starting of the session itself, I said, I explained about the definition of the processing. We are considering, according to today's sessions, I'm going to take the input is image only. So here, type of process are, different type of process are there. So what are the type of image processing mean? First is visualization, recognition, sharpening, restorations, pattern recognition, retrieval, we can able to do. What is this visualization? Suppose we are going to be find the object are not visible in the image. That's a visualization. Recognition means is distinguish or to detect the object, the particular object in the particular image. And sharpening. Here, we are going to be create the enhanced image from the original image. See, usually these are the sharpening and restoration we are doing nowadays. We are doing for the pre-processing. Usually, whatever the input we are getting, not only the images, suppose any files, any informations, we have to do the pre-process method. Maybe some of the column is not filled, some of the row is not filled in the Excel sheet. We have to be fill it according to our neighbors. Like this way, here we are doing the sharpening and restorations based upon the nearby pixels and we are giving the very clarity image, then only we can able to do our further process. So these are the concept processing before going to be do our research. We have to do all these pre-process method. The pattern recognitions measures the various patterns around the object in the image. Next is retrieval. We are retrieving from the database and which is we wanted because we are having in the Google. We want any information or any pic relevant to which we want. For example, red color car I wanted. So from this red color car, we are going to be get it from the large database very exactly. That is the concept of the retrieval. So these are the applications will be there. Here we are, maybe we can able to just, I said is very few applications only, but we can able to do lot also. Once I completed and what are the other research applications also, we can go with that also, not just because here today I'm planning to tell very less only because I can't able to cover all, and within that also what I plan means some of the concepts I wanted to go little bit deep. So these are the applications. So the medical field we can able to go with this image processing and robot visions, remote sensing, pattern recognitions, video processing, plant diseases, animal skin diseases, image authentications. We can able to get some water quality management via satellite images. And we can able to brain tumor detection or skin disease detections. All these we can go for this. All are the application of the image processing. So here They said about this sharpening and restorations, what is will be there. In the last slide itself, I said these are the pre-processing concepts we can able to do it. So how this restoration is going to be performed means reversing the process, that is blurred the image, and such performed by image point source and use the source images, which is called the PFO, that is going to be restores the image, lost the blurring process. So these are the process will be there in the sharpening and as well as the restoration. Next, this objective of restoration technique is to reduce the noise. What are the noise will be there in the image? It is going to be reduced and it is going to be recover the resolutions loss. What are any loss will be there? The resolution is not good because already I said this is a pre-processing. Then only we can able to do our research and what we can able to detect. For example, it's a tumor will be there in the images or it will be there and all. We can able to detect very properly. And this image processing techniques are performed either in the image domain or in the frequency domains. Okay. Any other domains we can able to do it. What does this image domain and frequency domain means? Image means that is a pixel oriented domain and a frequency based, because the DWT and DCT domains based also we can able to do it. And sharpening, it is an effort to apply to the digital images to give them a sharper appearance. Okay, so we wanted suppose we are also taking daily, most of the people's daily we are taking the selfie, and what we are doing afterwards, we are doing some of the restoration and also the sharpening, because we want to we are enhancing our pictures to look good, good purpose only. So here is also the concept is before going to be implement of our technique, we have to do the this pre-processing technique. The dull images are those which are poor at the edges. Okay, that is also happen. Next, this medical field. Nowadays, if anybody wants to do the PhD or anybody want to do the research in this area, otherwise using the concept of the machine learning, nowadays many researchers, they are working on this medical field. Because lack of due to some lack of all the instruments, lack of doctors, all this particular system is helping, as well as it is helping to the doctors also to give the rectifying and predicting the diseases or so much will be there. So this is the main field, main applications of the image processing. It imposes the use of exploration of the 3D images or 2D images data sets of the human body. That is mostly it is from the CT, the commutated tomography, or MRI scan images. With this CT or MRI scan images, we are working further and we are predicting and we are detecting the diseases, on giving some of the suggestions, and we are doing the some of the authentications and giving some of the information about the patient also with the help of all this. Because MRI scan, they are taking per day, they will take more than 100 or 1000 or 2000 like this way in one hospital or another they are taking. But maybe due to get the authentication purpose also, this MRI, this medical concept, the image processing, medical image processing, we can able to use. And this process is carried out by radiologists, engineers, and clinicals to better understand of anatomy of either individual patients or population of the groups also. This will be helpful for us. And this is the Xray. So with this also, this is a CT scan. Okay, it's a grayscale intensity. It depends on X-ray observations, and MRI is also will be there. Okay, so this medical field, it is going to be reducing or removing the unwanted noise, and also artifact with the image filter, and cropping and resampling. These also processing, cropping and resampling this input data to make easier and faster to process image. Using the segmentation tools to identify the which particular regions is needed, and automatically technique of AI based concepts also we can able to do with this medical field. And this applying the measurements and statistical tools to identify what the parts of the image data will be there and where it will be there, and everything we can able to get it, and the performance of all this we can able to understand all this. Okay, next is robot vision. It is having some of the 6 steps will be there in this robot vision. So here sensing the process yields to the visual image. Okay. Next is we are going to be do some of the pre-processing here. Pre-processing here, that is noise detection, enhancement is we are doing maybe noise, not only noise reduction, whatever it may, we can able to do it. Maybe some of the part is not good, maybe we can able to crop it. All this comes under the pre-processing. We can able to do the sharpening. Then segmentation they are doing. The third steps is the segmentation. Here they are partitioning the image into object of the interest. That means which object we want. For example, we are going to be take one of the brain tumor image. Okay, so in this brain tumor, where the tumor we have to be identified. So where it will be there, and what is the size of the tumor? Maybe this is the early stage or in the middle stage or in the end stage, and all based upon the growth of the growth of the tumor, we can able to detect or we can able to identify. So this particular segmentation concept, it is going to helping us to understand about the where it will be there and all. Then description, we have to do the computation of the features to the different objects we have to be performed, and recognitions we have to do. This is process to identify the recognition, means we are processing to identifying the objects. Suppose in the satellite we are taking, for example, one of the applications I said is water quality management. Someone raised the hand. What, ma'am? Usha, ma'am? Anything you want to say? Okay, nice. Then recognition, the process to identifying the object. For example, I said is one of the application is we can able to identify the water quality management. Otherwise, in the environment, how much it is affected, and where the ice will be there and where not, how much size of the ice. From the help, which the help of the satellite images, we can able to say very clearly how it is going to be there and where it will be there, when it will be melt, how it is converting. Otherwise, water area, how much area is occupies, and what is the pH level, and everything with the help of this recognition concepts, we can able to identify. That means it is identifying where the particular ice will be there and how much ice and everything. It will be identifying. And interpretations is assigning the meaning to the group of objects. This is the operations of the vision systems. Here, sensing and as well as digesting the image data. So here we are capturing the images and we are doing analog or a digital, and we are making that is the digital image. So this is called the particular initial steps of this we are doing, and typical technique we are going to be applying, and sampling and quantitation and encoding, all this we are doing in that. Next, acquisition, the process only we are acquiring from the hard copy of the image to soft copy of images. We are capturing and we are doing and sampling, and we are doing the quantities, the amplitude, and giving the results in the digital image, and we are arranging all this. So next is remote sensing. This is one of the application. This remote sensing is the process of detecting or monitoring the physical characteristics of an area by measuring the or reflecting emitted radiance at the distance using the satellite. Is it just now only I said no? some area, some part from the earth, we can't able to go. We can't able to go and do it, and we can't able to calculate how much water surface will be there, how much area that the forest is covering, and then how much area the ice are covering. All these and all, no, we can't able to. So with this concept, we can able to identify and we can able to proceed with all this with the help of this remote sensing concept. Here, some of the example I want to say. The cameras on satellite and aeroplanes take the images of large areas on the Earth surface, and that is going to be allowing us to see much more. We can able to see when standing on the ground. Yeah, suppose in the ground itself we can able to see. So this is also one of the applications. Just we can able to see what will be the and the longest area we can able to see. Next, the sonar system on ships can be used to create the image of ocean floor without needing to travel to the bottom of the ocean. Okay, like this way also this remote section is taking the place, because no need to go bottom of the ocean. From the top of the ocean itself, with the help of this remote sensing, we can able to capture the peak, and with that know what are the objects will be there, what will be there, we can able to go with that. Then camera on satellite can be used to make many images of temperature changes in the oceans. I explained, the concept, one of the research we can able to do with this, because there are many lagging will be there, because they are not many researchers, they are not going with this. But if you want to take this, we can able to predict some of the future, the temperature, how it will be changes and all, because a lot of changes is happening in the ocean nowadays. So that it will be very helpful. The image processing concepts with the machine learning, we can able to identify and we can able to predict. Based upon that, we can go with this good attitude. All this. Next, the pattern recognition. The pattern recognition is the process of recognizing the patterns by using a machine learning algorithm. This pattern recognitions can be defined as the classification of the data based on the knowledge already it's gained or the statistical information extract from the pattern of the representation. So this pattern recognition, it will be very helpful to identify maybe text recognitions, or lot will be there. The pattern means whatever it may, or circles, wherever there will be there in the circle, all these and all, some pattern it is going to be wherever it is going to be matching, or all this this concept, this pattern recognition is helping us to do with this machine learning concepts also. And this recognition system should recognize the familiar patterns quickly, and it will be very accurate. And this recognize, and it is going to be classify unfamiliar objects, and accurately it is going to be recognize the shapes and objects of the different angles. That is also this concept, this pattern recognition concepts. It's going to be finding all these features and identifying the patterns and objects, even when partly hidden also. Some of the part also hidden, and half of the part only we are having. We can, with this concepts, we can able to identify and recognize the pattern is quickly, and with automatically we can able to do it. So this is the advantage. Here it is going to be solves the classification problems, and it is going to be solve the problem to fake biometric deduction. So this is also one of the major issues will be there in the image processing. So this concept, it is helping us to solve the problems, and it is very useful for the cloth pattern recognition, for visually impaired the blind people. For the blind people, this cloth pattern recognition is helping for to do their own issues, or they can able to leave their world, and we can recognize the particular object from the different angles also. It will be going to be done. Next is video processing. The initial itself, I said about, I'm going to be tell about everything. It is a image only. There's no image processing. Here the input I said, I'm going to be take only image. It's not like that. But most of the works I'm going to be tell about this image only. But here, all these, what are the processing I explained, no sharpening, all this, so much application process I said. Everything we can able to go with video processing also. All the works we can able to do the video processing. Here the input is some videos. In image we take on, and the f of x comma y is the intensity value, is the pixel value I said. Here each and every frames we have to be do all these calculation, all these, and image authentication we can do it, and audio video authentications, all these also we can able to do with this. This processing is growing importance in the variety of markets such as video surveillance and video conference, okay, and medical imaging and military imaging. All these we can able to do with this image processing, and this applications is to enhance the quality and the medical purpose. It is going to be measure or understand of the parameters of the human bodies. Example, blood flow in the fractured veins. All these also we can able to do it under the concept of video processing. Next is this image compression. It is going to be reducing the memory requirements when storing the images. This image compression is also one of the process of image processing. This will be reducing the memory. And next is, it's a sports. It's capturing the motion of the athlete in order to understand and improve the performance. So this is also comes under the in video also. Each and every images we can able to compress, and we can able to make it. It's like a videos. Nowadays we are also doing so much app scheme for this. This concept will be there to reduce the memory, and we can within that we can able to store more images or all this. And the sports is comes under the athletes movements, how they are moving, and improving the performance purpose we can able to go with. And remote control will be the TV productions and the surveillance. It's going to be detect and track the individuals of the vehicles. Surveillance also we can able to do with this, and rehabilitations to access the locomotion abilities, and the motion pictures. It's going to be capturing the actors' motions in order to produce the special effect based on the graphics. All these will comes under this video process. And photo editing, biometric also will be there to measure the unique parameters of the persons. All this we can able to do with this. Next. So up to now, I just said about what is image processing and what are the pre-process will be there and what are the applications will be there. And in image processing, it's like a text processing also we can able to do. See, I said is image is the input, and next I said about the video, that's a frame is the input, and text also we can able to take it, or audio also we can able to. So in this image processing, maybe the input as image, that means image, otherwise text or audio or video, anything we can able to go with that. So up to that I said about this all applications, and where we can able to using and where they are using and all. I said just outline of all this. So now I want to tell about one of the research under the image processing is plant diseases. This is in nowadays. We are not much more people are not concentrating on the this field actually, because they are not showing the interest. But this is very necessary for us. This automatically, this plant diseases in main farmers know this concept is going to be helpful for them. The automatic identification of the disease that can be occurred to plantain trees over the UAV multispectral images. So automatically it is going to be identifying the diseases. So for us, no, we are keeping just 2 to 3 plant at home only. Within the 3 to plant, no, 6 months once or 2 months once, and some of the leaves will affected and some of the plant will affected. We are not showing this so much interest. Okay, this is affected. Then what will happen? Some trees, no, it will grow very slowly, and the production will be less, or something will be happen. But we have to think about the large area. In the largest area, the acre wise, the people are doing the field works. Nearly there's so much acres. The acres wise means this particular UAV, it is capturing the images. With the images, we are identifying the diseases and what are the diseases will be there, and how to give this particular system. It is going to be giving the how to protect and giving the solution of the rural area people. Okay, the focus on unhealthy regions of the plantain trees in the field. And the stage wise, it is going to be do the modification and identification and monitoring that is going to be implemented using the deep learning algorithm. So this stage, you know, this not in the early stage. If you are going to be identify the disease, definitely we can able to the survival of the plant, the survival of the plant will increase. It's hello, I'm audible.
Now it's audible only, ma'am. But in between, it's
audible only, no? My screen is visible.
I think
Maybe you didn't get it my voice. Pardon, I didn't get you properly.
Your voice is breaking, ma'am.
Due to the power, just now only the power went. Maybe that's it.
Now it's clear only.
That's why I'm asking.
Okay.
My screen is.
No, ma'am. Screen is not visible. Screen is not visible, ma'am.
Okay, I'm doing, ma'am.
Okay, ma'am. Okay, ma'am.
Now, ma'am.
Yes, ma'am. Now I can see it. Okay, ma'am. Now it's clear.
In between, power went. That's why maybe.
Okay, okay, ma'am. Okay.
Okay. So these are the type of diseases will be the infectious diseases, bacterial, fungal, viral, and all these diseases will be there in the plantain. And with these, no, the banana leaf rust, leaf spectral, and all these are the diseases. So these are the diseases. If you are going to be identifying with the help of UAV images, we can able to give the surveil of we can extend the surveil of the plant. So this method, it's going to be identifying the diseases and very frequently affected the yield of plantain area, and allows users to automatically to entire process of the disease detections from images captured through UAV. And the deep learning algorithm, it is very good for to identifying the diseases of the plantain tree in the early stage. And this is going to be provides a good accuracy in the prediction of the plant diseases. It is giving this deep learning algorithm. And no, the infected diseases are identified, the farmers is advised to use the pesticides as a cue. So this particular system, not only the identification, we can able to give the advice. That means you people have to be used, this diseases is affected, the particular disease is affected this particular plant. So you go on the use of this pesticides for the curing purpose, and all these we can give the instructions or suggestion of something to the farmers that will be helping us to increase the more productivity of the cultivated plants. And this is the important role of our agriculture. And this machine learning or agriculture UAV can be can together, it is extending the food security by the limiting, and food loss due to the pest and the diseases will be the next. Next is the animal skin diseases also will be that is also one of the applications. With this machine learning or deep learning concepts, if we are going to working of this animal skin disease, it is helping us to identifying the disease in the early stage, and that is going to be give the it's animal viral diseases which cause several economic problems, including the significant milk yield loss. My voice is audible.
Yes, ma'am.
Yes, ma'am. Okay. Because here the questions will be there. That's why I'm thinking that whether my
Yes,
voice.
madam.
It's
Okay, nice.
Audible, madam. Audible.
Yes, sir. Then nice, sir. Very good.
Okay.
Okay. So the next is skin disease. This is also most of the countries, many animals are affecting. Because of the reason it is spreading some of the disease of other animals and as well as the human beings also. The early stage, if we are going to be identifying these are the problems, it is going to be giving the prediction. If the prediction of the disease, it is helping to withstand for the long period of the animals. So, and no, the trade emissions, the fertility, the milk yield loss, the several problems or milk yield loss will be happening with this diseases, and no infertility also it is happening, and abortion also happening with this disease problems, and trade limitations. Sometimes the death is also happening. So this virus is transmitted to infected to non-infected animals also through the direct contact by mosquitoes, flies, and sticks also. This the particular disease can be also spread through contaminated feed and water and equipment also. So these are the ways the animal diseases are spreading in around. The specific objective of why we have to be study this animal skin disease means this particular it is going to be give the large data set. It also we can able to work with this, and the particular selected the segmentation concept and deduction. With that, we can able to detect this animal lumpy skin diseases. And to construct or deduction of the model, it is going to be identifying the high sensitivity, and to evaluate the performance, that is going to be with that, we can able to identify how the particular deduction is helping us helping us to detect the particular model will be there. These are the fundamental steps will be the, suppose if you want to work in image processing, before going to be start your research, kindly concentrate all these fundamental methods, then get clarity of all these, then you go and proceed with your research. So first we have to be output of this process generally or the images, and we have to be processed with some of the color images, and what is wavelet and what is DCT and what are the multi-resolution process will be there and all. We have to be get some informations. And morphological processing, how it is be happening. Then no, morphologic means Rajini will come, then afterwards line will come. No, so that's the concept. We are changing the one phase to another phases, the how it is modifying. So that is also one of the process in image processing. And restorations and knowledge based segmentation, image enhancement, representations, image association, object recognitions, and problem doing. All these they are the fundamental steps of the image processing. So up to now, I just said about is like one of the domain. One domain is the image processing. I said about some of the outline of the image processing, what is image processing, and under that what are the applications will be there. From that, no, what are the problems will be there. Just a few problems only I said. I didn't say a lot of problems. If time occurs, maybe the time is going to be permit, maybe I can able to explain one or two concepts somewhat very deeply today. So before, no, I want to tell how this machine learning nowadays in everywhere, wherever we are turning the machine learning, artificial intelligence, deep learning, these three words only it is coming to us. In everywhere they are using because why we are using this, these are the techniques, it's helping us to predict or to the detection, and it is giving the more accuracy. The performance are very good. The accuracies are very good because of the reason we are concentrating on automatically. The system is also automatically it is working. That is the concept we are going with. These today we are concentrating on. These are the concept. See, this artificial intelligence is it's a one of the domain. With the artificial intelligence, we are going to be that the machine learning comes under the artificial intelligence. The deep learning comes under the machine learning. Okay, from this peak itself, you can able to understand how it will be there and all. Okay, so machine learning is different, deep learning is different, artificial is different. It is not like that. All three is together. Okay, so the machine learning is a field. It is going to be studying. It's give the computer to capability to learn without being explicitly the programmed. Okay, so without explicitly the program, we can able to learn the system. So here, with the help of machine learning, we are learning actually. See, I'm before going to be start the session. This about this machine learning, I have to tell. I'm going to be give some of the example. I'm having 10 mangoes. I'm having the 10 mangoes because machine learning means we are learning the system. Actually, before going to be implement, we are learning the system. Based upon that only, we are going to be working. So how I'm going to be saying 10 mangoes we are having. Within the 10 mangoes, some mangoes are ripened, some mangoes are raw. Okay. See, as a human being, how we will identify raw or ripen? Based upon colors, based upon smell, or touch. With the touching of the mango itself, we can able to say, yeah, this is ripened and this is raw. Like this way, we can able to identify the ripened and raw mangoes. Okay. So now, what are the features we are used here? color, or texture, smell, maybe with the touching of also we can able to say. Okay, as a human being only we can able to go with that. But system means we can't able to go with that. Maybe weight also we can able to say with the weight. Okay, some of the weight which over more than 500 grams will be there means definitely that will be ripen. That won't be raw. Raw means maybe it's a small stage, it will be raw. Like this also we can able to guess. Okay, so out of 10, no, 8 are ripen or 2 are raw. Okay, so with this, no, we know we can able to judge. We can able to learn the system, how we identified, how we got the information, all this. Then 11th mango is coming. Okay, the 11th mango is coming. We know with that, no, with this 10 data, no, we can with this the informations from this learning, we can able to say the 11th one is ripen or raw. So this is the concept of machine learning. So we are having the existing data. With the existing data, we have to be learn the system very properly. Once we learned very properly, we completed, we got the accuracy. Then 11th one, it is going to be entering. We can able to say, yeah, this is ripen and this is raw. Automatically, it is going to be say. So because of the reason, the time and accuracy, all these are increased more. So that's why we are concentrating machine learning concepts nowadays. And no, we are having types or more types will be the supervised machine learning, unsupervised machine learning. These are the very famous, and semi-supervised learning and reinforcement also will be the. What is the supervised? The machine learning types or 4 types will be the under the supervised. These are some of the applications they given here. Okay, some of the applications from the supervised learning, we can able to predict the housing price or medical imaging. We can go with unsupervised means we can go with customer segmentations and market-based analysis. And semi-supervised learning means text classifications and land finding on GPS data. Then reinforcement learning means optimized the marketing or driverless car. Okay, so that's a concept. Okay, so these are the applications which will be, I said, based upon this types. So what is this? You have to be know what is supervised. Supervised means, which I said, no, the example, the 10 mangoes, about the 10 mangoes I said, with that, no, all the input will be the, okay, based upon the 11th one, automatically they are telling about that. Okay, so that's a concept is called supervised. Unsupervised means without see, for example, one more example also I can able to say, we are learning the car. Okay, without driver, we are going to be learning the car is called the unsupervised. We are not knowing anything. We are not knowing input, because in supervised, we knows what is input. Based upon that, we people are getting the output. Okay. From this input and output, we are going to be predicting the new arrival. But unsupervised, we are not knowing input and we are not knowing output is also. From that, no, we are learning from that. So from the based upon the system, we are learning. The semi-supervised means is half of the concepts will be there in the supervised, some of the inputs will be there and some of them are missing. All this will be happening. And reinforcement means is full and fully, it is not going to be depends on any of the inputs. Okay. This supervised learning technique, we train the machines using the labeled data set, and based on the training, the machine predict the output. So based on the training, okay. So based on training means what? What is the meaning of the training? From the 10 mangoes, we trained. Okay, the each and every, with the help of the features, we trained. Based upon that, data set already we are having. We know the input output of
Excuse me, Rosline ma'am. Your voice is breaking. Rosline ma'am? Ma'am?
Ma'am is having some network issues, maybe, ma'am.
Okay. Okay, let us wait for some more minutes, ma'am.
my voice is audible, ma'am.
Yes, ma'am, we can hear you now.
Yeah, okay. Okay. See, the screen is also
But screen is not visible, ma'am.
visible, ma'am. Screen is visible.
No, ma'am. No, we can't see.
Participants, please wait. Ma'am is having some network issues. She will join soon. Please kindly wait.
Yes, madam. Yes, we are waiting.
Sonia ma'am.
Yes, ma'am.
Ma'am has not turned up. Shall we call her?
Yes, ma'am. She's trying to join, I think.
Okay.
Sorry for the inconvenience, ma'am. Due to the network issue, some of the interruption happened.
No problem, ma'am. Please continue.
And now immediately I
No
joined.
issues.
You have to be make it as a panelist, no? Then only I can the voices you can able to hear.
Audible.
That's the reason it has happened. Okay, sorry.
No issues, ma'am.
Sharing my screen, ma'am.
Okay.
Okay, it's visible, ma'am. My screen is
Yes, ma'am. Yes, ma'am. We
Yeah.
can see this supervised machine learning page.
Yes, ma'am. See, we are discussing about what is supervised to know. For example, we are taking one input data. That data sets we are having cat and dogs images are there with the shapes and size of the tail of the cat and tail of the cat and dog and shape of the eyes and colors, height. With that, no, the dogs are taller and cats are smaller. With these features and all, we can able to predict cat or dog. All this we can able to categorize. Okay, so this supervised machine learning, it is going to be classified into two type of problems. One is classification, another is regression. The classification means the pic itself we can able to understand two colors of the balls we are having in the single bag. So we are going to be dividing the two different balls differently. So that is the concept, is the classification. This regression, it is having the same set of images only, because the blue color balls only we are having, but putting some of the difference of all this, the weight or size of all this, we can able to divide the concept. So that's called the regression. On this classification algorithm, we can able to use to solve the classification problem, which output variable is categorized yes or no, or male or female, or red or blue. All this we can able to go with this classification, and all this algorithm, it is going to be predicting the characterize the present in the data set. And some of the real-time examples of classification algorithm of the spam detections or email filtering, we can able to do with this classification. And these are the some of the algorithm: random forest algorithm, decision tree algorithm, logistical regressions, and support vector machine. If time permits, definitely after explanation of all this concept, I am going to be explain one of the algorithm. That algorithm also I'll explain very clearly, and as well as I'll explain with the example. And regression, the regression algorithm are used to solve the regression problem in which there the linear relationship between input and output variables. These are used to predict the continuous output variables such as market trends, weather predictions. All these we can able to do with the help of this linear regression also. Some popular regression algorithms are simple linear algorithm, multivariate regression algorithm, decision tree algorithm, lasso regressions. So end of the program, I'll explain what is linear regression algorithm, how to implement. With the example, I'll explain. And advantages and disadvantages of supervised learning. What are the advantages? This supervised learning, it is going to be work with the labeled data set. So we can have an extract idea about the classes of objects. These algorithms are helpful in predicting the output on the basis of the prior experience. So with the old experience, we can able to understand the new item. Okay. Disadvantages. This algorithm are not able to solve the complex tasks, and it may predict the wrong output if the data sets is different from the training data. Okay, so the test data is different from the training data. Definitely the prediction will be wrong only. It going to be requires lots of computational time to train the algorithm. Okay, so to taking the training algorithm, it is taking the more computational. So that's the drawback of the supervised. Application of the supervised, where we can go with the segmentation, medical diagnosis, fraud detection, spam detection, speech recognitions. All these are the application of the supervised. Next is unsupervised machine learning. This learning machine is going to be trained using the unlabeled data set. Labeled set is called as a supervised. Here is unlabeled data set we are going to be used in the training of the machine, and it is going to be predicts the output without supervision. Okay, so the main aim of unsupervised learning algorithm is to group, and we are categorized in the unsorted data set according to the similarities and patterns and difference. So these machines are instructed to find the hidden patterns. Okay, each and every data, it is having some of the pattern only. So the machines are going to be identifying the hidden pattern from the input data sets. This is going to be categorized of two types. One is clustering, and as well as the another one is associations are there. This clustering technique is used to when we want to find the inherent group of from the data, and it is way to group the object into the cluster such that the object which is most similar remaining in one group and have the fewer or no similarity will be objects of the other group. Okay, the clustering concepts already we knows very well, which is having the similar concepts, similar points or similar items that will be we are keeping in one net, and suppose there is no similarity will be go for the another group. Otherwise, some have the less similarity will be have the another group. These are the popular clustering algorithm: K-means clustering algorithm, mean shift algorithm, DB scan algorithm, PCA, principal component analysis, independent component analysis. These everything the just some of the popular algorithm in machine learning. Associations, the rule learning is an unsupervised learning technique. This is already we know because there are the two types. One of the technique is associations. It finds in interesting relationship among the variable with the largest among variable within the largest data set. The main aim of this algorithm, it is going to be finding the dependency on the one data item on the another data item, and it is going to be mapped those variable accordingly so that it can be generate the maximum profits. So the popular algorithms, the algorithm is mainly applied to market-based analysis, web usage mining, continuous productions, or what will be this association concepts, association unsupervised concepts. We can able to use that. These are some of the famous or popular algorithm in the association. Aperia, Eclat, FB growth algorithm, all these. These advantages and disadvantage of unsupervised. Advantage can be used. The advantage of unsupervised, it can be used for complicated tasks compared to the supervised one, because these algorithms work on the unlabeled data set. So the labeled data set, it is taking the more computational time it is requires for the training data set, but it is not required like that. So that's a major advantage of this unsupervised. And these algorithms are preferable for various tasks, as getting the unlabeled data set is easier as compared to the labeled data set. And disadvantages, this algorithm can be less accurate as the data set is not labeled, because of the reason it's not labeled, and algorithms are not trained with the exact output in the peer. Working with this unsupervised learning is more difficult as it works with the unlabeled data set and does not map with the output also. So these are the advantages also will be there in the unsupervised. Next, applications. What are the applications comes under that? This unsupervised means network analysis, recommendation systems, anomaly detections, and singular value decomposition. This semi-supervised learning. The semi-supervised learning is a type of machine learning algorithm that lies between both supervised as well as the unsupervised. It is the intermediate ground between labeled and unlabeled data. Okay, and it is going to be used the combination of labeled and unlabeled data during the training period. So this concept is called the semi-supervised. Advantage of this semi-supervised are, it's very simple and very easy to understand, and it is highly efficient, and it's having some of the drawbacks of the supervised, unsupervised also it is solving. And disadvantages is iterations results may not be stable, because one iteration will get 20, and then another iteration it will be getting 10, then the accuracy it is not matching that much, because the iterations are not stable, and we cannot apply these algorithm to the network level data. Accuracy is also low only. And next and last type of machine learning is reinforcement learning. Reinforcement learning, it's going to be works on the feedback based process in which an AI agent, that is a software component, automatically explore its surrounding by hitting and trial and taking action, or learning from experience and improving its performance. This particular agent, it gets a reward for each good actions, as well as it is going to be punished for the bad action, whatever it may. Hence, the goal of refreshment agent is to maximize the rewards, or good or bad, it is going to be maximize the rewards. For example, the child learns the various things by experience in his day-to-day life. So that's called the reinforcement. And categories of reinforcements, it is having the two methods. One is positive reinforcement learning, another is negative reinforcement learning. What is this positive reinforcement learning? It's going to be specifying the increasing the tendency that going to be occurring in the this behavior would going to be occurring, the behavior would be occur again by adding the something, and it enhances the strength of the behavior of the agent, and positively it going to be impacted. Okay, but negative is going to be opposite to the positive reinforcement. it is going to be tendency to specifying the behavior could occur again by avoiding the negative conditions. So that is the positive. It is going to be, it is avoiding the negatives. So that is a difference between the positive and negative reinforcement learning. Next, real world use case of the reinforcement learning is video games and reinforcement management, robotics and text minings. We can able to do with this. Advantages and disadvantage of reinforcement. Advantages, it is helping to solving the complex real world problems which are difficult to solve by general techniques. And the learning model of oral is similar to the learning of human beings. Hence, most accurate results can be found, and it helps in achieving long-term results. Disadvantage of this reinforcement, it is not preferred to the simple problems, and the algorithms requires the huge data and computations is also required. And here it is going to be lead the overload of the states, which can be weaken the results. Next, I'm going to be tell about this deep learning. The deep learning is a subset of, already I explained, it's a subset of the machine learning only. It is essentially the neural networks with the three most layers. These neural networks attempt to simulate the behavior of the human brain. It is matching the ability to allowing it to learn from the large amounts of the data. This going to be derives from the AI applications as well as the services is going to be improving the automations and performing the analytics and physical tasks without human interventions. This technology lies behind everyday products as well as the services such as maybe voice-enabled TV modes or credit card fraud deductions, or well as the emerging technologies are moving around that. What are the difference? Okay, what is machine learning and what is deep learning? First, we should know the difference between these two terms are very clearly before going to be do our research. The machine learning algorithm leverages the structured labeled data to make the prediction, and meaning that it is going to specifying the futures or defined from the input for the model or organized into the tables. But deep learning, it is going to be eliminates some of the data pre-processing that is typically involved in the machine learning. If we have to work with the machine learning, we have to go with the pre-processing. The initial of the class session itself, I said what are the pre-processing will be the before going to be start all this research works, the minimum pre-processing steps we have to be done, we have to be do it, and we have to be train the data in the very proper way. Then only we have to be go with that. But deep learning, we are not concentrating much more on for the pre-processing. The algorithm can ingest and process unstructured data, because the machine learning, we wanted that some of the trained data, the structured data are required. But in the deep learning, we don't want that means structured data. Without structured data also, like a text or images or automated feature, automatically it is going to be do the feature extraction. All the pre-processing steps is automatically it is doing removing of the dependency on the human experts. Actually, we have to do only, but machine learning we have to do in the each and every process. Segmentation we wanted it in, we have to do it, and some noise reduction we have to do, means we have to do all this. But in this deep learning algorithm, the algorithm itself, it is doing all this process. So that's the main difference between these two. This neural networks works consists of multi-layer. Okay, it's a multi-layer of the interconnected nodes. Okay, it is every nodes are interconnected, each building upon the previous layer to refine or optimize the predictions or categorizations. This process of computations through the network is called the forward propagations. Actually, we are having the forward propagation and backward propagations. If we are going the towards, okay, the going the forwardly, so we are not going to come back to for our initial stage. But in the back propagation, again, we people will come back to the initial state. Again, we have to do the iterations. So that is called the back propagation. Here, the input-output layers of the deep neural networks are called the visual layers. The input layers is where the deep learning model indicates the data for the processing. The out layer is where the final predictions or classifications is going to be made. Okay, so another process I said, no, the back propagations. This algorithm, it is like a gradient descendant to calculate the error in the predictions. Okay, so this algorithm mainly we are concentrating of the error. What are the error will be there to in the prediction? The prediction itself, what are the errors will be there with the help of this back propagations. We are identifying and we are adjusting the weight and bias. Okay, that we are adjusting based upon the predictions of the function by moving the backward through the layers in an effort to train the model. The forward propagation and backward propagations, it's going to be allow the neural networks to make the predictions and correct for the errors accordingly. The over time, the algorithm becomes gradually more accurate. Okay, so here, these are some of the algorithms will be there in the deep learning. Convolution neural network. In every word, we heard this word because this is more convenient to work for this deep learning algorithm and more accuracy will be there. And because now already I said the machine learning and deep learning concepts, because that unstructured data also, this convolution neural networks is working and it is this algorithm itself, it is doing the features extractions. Next is recurrent natural network and Boltzmann machines and transfer learning, generating adversarial networks and auto decoders. These are the algorithm for deep learning. Next, convolution neural networks. Okay, so I'm going to be telling about what is CNN. So some of the basic concepts of CNN I'm going to be explained now. Convolutional neural networks are distinguished from other neural networks by the superior performance with image or speech or audio signal inputs. It's having the three main layers will be there. The first is convolution layer, second is pooling layer, third is FC layer. Okay, so the three layers I'm going to be explained how it is working and all. So the convolution layer is the core building block of CNN and it is where the majority of computations occurs. And it requires the few components which are input, filter and feature maps. We will assume the input will be the color image and which is made up of the matrix of the pixel in 3D. And it means that the input have the three dimensions, the height or width or depth or whatever it may, it will be there. And these have the feature detector. It is also known as we can able to call the filter or we can able to call the kernel also. This particular is going to be checking the feature will be present or no. That particular checking of features, that's called the convolution. The process is the convolution. See here, this is the convolution layer. This is the image. See, which I'm showing now, 941. So here, the filter size we taken 3 by 3 filter. This is the filter or kernel or whatever it may, we can able to say. This is the image we taken. With the image, we taken 3 by 3 filtering kernel. That's the reason we here with this 3 by 3 matrix, we are considering the original images. With this, no, we are doing. We are going to be do the filtering. And with the filter, how we are doing, see, this is the example, just multiplying this 9 into 0, 4 into 2, 1 into 1. Okay, like this way we have to be multiply and afterwards, we have to be add. So then 16. So this size of 3 by 3 size, how we reduced? See, in the single value. Okay, so this is called the output array. This is the input, this is the filter. Maybe kernel also we can able to say this is the output. So this layer, from this layer to this layer we converted now. Okay, so that is called the convolution layer. Next, no, the convolution layer, it converts the image into numerical values also. We can able to convert like this also. And this allowing the neural networks to interrupt the extract the relevant pattern. The pattern also. See, here, no, what the cycle is having, all the shapes we have to be collecting and assume trying to determine in the image cycle. And based upon that, the individual part of the bicycle make up the lower level pattern. Okay, initially we have to be go with like the lower level in the neural network, and we have to be next, we have to be go for the higher level pattern. And last is we have to be creating the features of hierarchy within the CNN. Then we are getting this, which we want in the cycle. So like this way, it is matching and it is deducting all this. Next is second layer, I said is what? Pooling layer. The pooling layer is also known as downsampling, conducts the dimensional reduction, reducing the number of parameters in the input. The pooling operation speaks the filter across the entire input, but the difference is that is a filter does not have any weights. Instead, the kernel is going to be applying the aggregations of function to the value within this particular field and the populating the output tray, which we got it in the last layer, convolution layer. Okay, so here there are the two type of polling layers are there. One is maximum, another is average. Here the filters are going to move across the input. Okay, it selects the pixel, which the maximum value it is going to be sent to the output array. As said, this approach is lens to use more often compared to the average pooling. This average pooling is going to be moves across the input. It is going to be calculate the average values within that. See, there is the maximum values we are going to be we are going to be considering, and comparing with that we are doing the pooling like that. So here we are going to be calculating the average value within the respective fields to send to the output array. Pooling layer advantages is it is going to be reduce the complexity and efficiency will be very good, and it is having the limit risks of overfitting. The last layer is finally connected layer. Each node in this output layer, it connects directly to the node in the previous layer. Okay, so this layer is performs the task of the classifications based on the features extracted through the previous layer and the different filters. Okay, so that's 3 layers I said about this. What is CNN? Okay, next is recurrent neural networks. Is what is that? Just I'm not going to be deep. Just I'm going to be tell about this outline of all this. What will be the under the deep learning? Just I want to say. The recurrent neural networks is a special type of artificial neural networks adapted to the work for time series data. And this particular data involves in the sequence. The feedback neural networks are only mean for data points and the independent of each other. Okay, so this is the input output of the sequence ht equal to f of ht minus 1 xt. The ht is here the current state, and t minus 1 is the previous state. Ht is the input state. Okay, so these are the formulas to implement of RNN. Applications. What are the applications? We will be there in recurrent neural means language modeling and generating the text, speech recognition, machine translation, image recognition, face detection, time series forecasting. All these we can able to. Then Bohr's machine is a model, more hidden layer with this directionless connections between the nodes. The training process in DBM needs to be adapted to define the training formations, weight, initializations, and adjustment parameters. Okay. This is the input. This is the classification layer will be the. This is the hidden layer. This is the future vectors. Okay. Then transfer layer, learning. this concept, first we have to be trained. This is also one of the concept, transfer learning. Okay, many people we didn't heard this word actually. This what is the concept of this means? It's a training as a base of network on the base data set and task. Okay, then we have to be repurposed to learn the features. Otherwise, we can able to transfer them. Okay, the second target network will be trained on the target data set and task. This process, it is going to be extended to the work if the features are general and as well as it's going to be both in the target task instead of specific to the base task. Okay, it's having the two approaches: develop model approaches, pre-train approaches. Okay, the inductive learning and inductive transfers. Inductive learning means it is learning like this, and it is transferring the data to be like this. Okay, this is a PC concepts. Next, generative. See, actually, from here, no, already the time is 3:40. So before I want to tell about this, one of the machine learning algorithm, I want to say already I said no. I'm planning to tell about machine learning algorithm. It's visible. My screen is visible.
We can see 4 PPTs list, ma'am.
1 minute, 1 minute. Now it's visible, ma'am. It's visible?
No, ma'am.
It's visible now?
Not it, ma'am. Gunashayan sir, can you see?
Shall I start?
No, sir. Can you see the screen, sir?
No, ma'am. Only the 4 PPTs.
Yeah. Same thing here.
Is sir? Now,
Yeah. Now we can see, ma'am. Linear regression in machine learning page.
Yes.
Yes.
One of the popular
Now the screen
machine
is
learning algorithms. Yes, sir. Thank you, sir. One of the famous popular algorithm is linear regression. Actually, I said the difference between the classification and regression. See, but somewhat detailedly I want to say, and with the example I'm planning to take today, the linear regression is the mathematical relationship between independent and dependent variables. Okay, so this relationship, it's having the portion and having the relation, making the most simple relationship between the variables. So y equal to mx plus c. This formula already we know very well. Here m is the slope and c is the concept, and here y is dependent and x is independent. Okay, the x value, whatever it may, it will be there, but based upon the x value, this y value will be going to be happen. So that's why this y is the dependent value. Here, the relationship between y and x must be the linear. The features must be independent of each others. And this homogeneity, the variance between the output must be the constant for different input data. And the distribution of y along x should be the normal distribution. So, regression is one of the easiest, most popular learning algorithm. And it is the statistical method that is used for predictive analysis. For the predictive analysis purpose, this particular algorithm we are using, and this predictions for the continuous or real or numerical variables, such as, for example, sales of something or salary of the persons or age or product prices, whatever it may, we can able to predict with the help of this particular concepts. Linear regression. This linear regression model, it provides a sloped straight line representing relation between the variables. Consider the below image. With this image. See here. These are the data points. This particular line is only we are going to be getting the classifying all these values. Okay. The value of X and Y variables or training data sets for the linear regression model for the representations. It's having also two types. One is simple, another is the multiple linear regression. What is meaning of the simple means it's going to be predict the value of the numerical dependent variable. Then such a linear regression algorithm is called the simple linear regression. Multiple linear means if the more than one independent variable, it is going to be predict the value. Okay, if we are going to be more than one, we are going to be predict the value. The numerical is going to be depending the variable. Then particular such regression is called the multiple. The linear line it is going to be showing between the dependent and independent variable is called the regression line. I said no, this is called the regression line. Okay, so the regression line can be shown two type of relationship will be the one is positive linear relationship, another is a negative linear. The positive linear relationship, it's going to be depends variable increasing on the y-axis independent variable, increases on x-axis. Then such a relationship is termed as the positive linear. The negative linear relationship means if the independent variable, it's going to be increases on the y-axis and the independent variable increases on the x-axis. The such a relationship is called the negative linear relationship. The negative linear relationship, if they dependent on the increasing on the y-axis and the independent variable increases on the x-axis, then such a relationship is called the negative. Okay. The shows. So I'll start with the one example for this regression. It's visible, ma'am. My screen is visible?
No, ma'am.
No, again no. It's no.
Yeah.
Stop sharing. Extra to be shared. Now it's visible, I think so.
Yes, ma'am. Yes, ma'am. Simple linear regression example.
Yeah. See, this is the example. Already I explained about all these, which I'm showing here. Slope and y interrupt, it's a constant, y interrupt form. See, actually here, with the help of this only y interrupt form, we have to be make a line, regression line. That's a concept. With the data, we have to be make a line. Okay, from that, we are going to be classifying. Okay, so here, the x-axis, all x-axis values are called independent, y-axis values are dependent. Okay, so here, I taken, this is the sum of the values I taken. X values are 1 to 6 and y equal to some values. Here, how many observations will be the 6 observations? Totally 6 numbers will be the, so I consider. Next, no, these are the calculations we have to do for this because due to the lack of time, I didn't explain the formula of linear regression, all this, but I'm planning to take the concept, how to implement in the small example. Okay, so X, Y, so this is the average we have to be calculate, the mean we have to be calculate for X and Y, and we have to be find X minus X bar. X bar is the mean, so that value we have to be calculate, and Y minus Y bar we have to be calculate. Next, this and this value we have to be multiply. Up to here, we can able to do, then X minus X bar the whole square we have to be calculate. So up to here, just we know very well from seeing the slide itself, we can understand, but how to calculate this Y cap. Okay, so that I'm going to tell you now. This is already I explained. So X, Y, X minus X bar that we have to be calculate. Next, X minus X bar and all these just we have to be multiply all this value. And X minus X whole square we have to be calculate. So how to do this Y cap? Okay, so from this, see, these are some graph. Some of the data are fallen in here and there. Okay, so from this, we have to be draw the regression line. This is our target. We have to be find this particular formula, the scatter plot. We have to be from the scatter point. We have to be find the models. Okay, so this is the M formula. Sigma x minus x bar y minus y bar divided by sigma x minus x bar the whole square. So already we know this value x minus x bar y minus y bar. So what is this value? 16.5 divided by 17.5. Where it will be the x minus x bar and y minus y bar. That value we have to be take it from that sigma value. So we have to be added all these the value. And x minus x bar sigma also the overall value we have to be taken and to be divided, and we are getting 0.9. So this is the formula y cap equal to c plus mx. Already we know. Then y cap equal to 5.2. Okay. Then c, then 0.9. So this is we have to be final. So now we know the value of m, but we don't know value of y cap and as well as this x or all this. So that we have to be find it. So how we will find it? C. From this 5.2 c plus 0.9 and 3.5. Okay, that particular value we have to be apply. Then we are getting the c. And from this the y cap, the regression line. So from y cap equal to mx plus c, the y cap equal to 0.9 in x plus 2.5. So here with this line we are getting the regression line. So it's the best line for our model. So we have to be find the best line. So next, after getting this line, we have to be substitute all these value. X is equal to 1, x is equal to 2, x is equal to 3. Like this way, we have to be find all this y cap. Okay. All this y cap value up to 6 value we have to be get. So that's the value I written here in the first slide. Here. Okay. So next, calculate the difference of the actual and estimated. So actually means what is the exact value will be the, and estimated means how it will become for tomorrow. So like this way, so this is the formula for standard error of the estimation. So it's the root of sigma y cap minus y the whole square divided by n minus 2. So that value already we know, just the supply it and 1.25. So these are the estimated value. Thank you. Any queries? Any queries will be the.
Thank you, ma'am. Participants, if you're having any doubts, please post in the chat so that ma'am can answer.
If you are having any doubts, you can ask. To identifying any problems in image processing, also you can ask your doubts. This actually.
Ma'am, in chat section, Dr. Karthikeyan posted 2 questions, ma'am.
Yeah, ma'am. It's going very fastly. Okay, you can see. Okay, if they are going to follow means I can send the PPT. There is no issue on that. We can't able to say, see, one of the persons is asked which algorithm is best for the machine learning. I said about many algorithms are the popular algorithm. Exactly, we can't able to say based upon the training. So this researchers, they have to be understand very clearly. We are depends upon the data set. Definitely, it will be vary. The same algorithm we are using. The algorithm is linear regression only. We are not changing the algorithm. But if we are changing the data sets are different, definitely the answer will be different. The accuracy did not going to be matched. Okay, so don't depend upon the particular algorithm that we can't able to say very clearly based upon the data set, because that is very, very important. You have to be concentrate on your data set very clearly. The futures which you are taking, that you should be very clear. Based upon that, definitely you will get the good results or good accuracy. You will get it. You can able to predict the explanations. Yeah, feature selection, no need to apply the special feature selection of for the deep learning. Is already I said deep learning itself, the algorithm itself, it is doing the pre-processing actually. So no need to go for the special feature selection of all this. No need to go for that. Or if you are going with that also, maybe you can get but good results, we'll get it or not, we can able to say all this. I want to ask if any software for plant disease recognition. Actually, we are a computer students. We have to be find the software for the disease recognitions with the help of ML. So that is our target. No, there is no. It's available. It will be available only. We can base upon that only. Many of the farmers, they are working for this. Okay, they are identifying the diseases actually. But we have to be. We are the computers. We people have to be make the software or system for the farmers to identify the diseases in the very less cost. So that is our actually our target. So we will go with that. So the research will be helpful for the farmers to identify the diseases to improve our productivity. Yeah, we can able to apply the machine learning algorithm for the numerical data. What data will be different? Already I said, no, it is not only for the image data. See, it's not going, the machine learning, it is going to be work for everything, not only for the images. As already I said, no, image, it will can work on video or text or audio, whatever it may, and some of the files also, file formats also, it will work. Okay, so it will be numerical data also, it will work. Whatever the numerical data also, we have to be do the basic call. That means a pre-processing we have to be do. That's that we have to be do only for everything. Actually, my name is Dr. Rosline. If any doubt, if you are having means, you can contact me. My number is 85004 55 203. Thank you so much. You given very good feedback for me. Thank you so much.
Yeah, that was an interesting session, ma'am. You explained very well. That is very informative too. Thank you so much for your time, ma'am.
Thank you so much, ma'am. Thank you. Thanks for your management to given this opportunities also. And thanks
It's our
to
pleasure, ma'am.
thanks to special thanks to Victor Sudha ma'am to invited me to deliver this session. Thank you so much. Thank you, ma'am.
Thank you, ma'am.
Shall I leave?
Yes, ma'am. Yes, ma'am. You can leave.
Thank you, ma'am.
Participants, we have posted the feedback form in chat. Kindly fill this form. This form will be active only for 15 minutes. Kindly fill this form. Kindly fill the form using the participation ID. Don't enter just the zeros or ones, please. So that, ma'am, if you have not filled this yesterday's form, no problem. Just fill this today's feedback form, ma'am. So if you have filled, you can leave the session.